So in earlier videos we've been factoring with a number out front. And the next extension of that is to be able to solve ones. And if I look at this, this looks like it's in the form of A, B, C, but it's actually not. Because we have something going on the right side. And the only way we're going to be able to solve this one is if we fix it first. Sneak a minus 3a after the 4, and so that when we go and we rewrite problem 1, we'll write 8a squared minus 9a minus 5 equals 4 minus 3a. So yeah, we want this to be A, B, and C, but since there's things going on the right side, that's not really what's going on. We always need the right side to be 0, so we need to move those things over. And we'll do that by subtracting 4 from both sides, and then adding 3a in the same step. Now our new equation will look like this. 8a squared minus 6a minus 9 is 0. So here we'd be looking for the factors of AC, which is 8 times negative 9. And maybe I do this in my head now. I'm looking for the factors of negative 72 that add up to negative 6. And even though we do it in our head, let's make sure we show it in these notes, because you might never want to cut that corner depending on how much you're comfortable carrying in your working memory. So 8 times negative 9 gives me 72. Sometimes it's nice when these end up being the factors that you use, but those don't give me 6. So we're going to have to try some other combos. Well, 1 and 72 does not work. 2 and 36 doesn't work. 3 and 24 doesn't work. So then maybe 72 divided by 4 gives me 18. No good there. How about 72 divided by 6? And so this 6 and 12 looks to be like our best choice. So I'll erase all of this, and I'll show that the factors ended up being 6 and 12, which means that the 12 has to be negative to give me that value of negative 6 out front. So we'll write 8a squared exactly as we see it, but when I see minus 6a, I'm going to write that as minus 12a plus 6a. So that became two terms now, just like in the earlier examples. Looking at the two terms on the left, I can factor out 4a, which leaves me with 2a minus 3. On the right side, I can factor out 3, which will leave me with 2a minus 3. And that'll be equal to 0. Now sometimes it's easy to leave out this equals 0, especially if you're so in the habit of doing the earlier factoring problems, but make sure that we have we got a different end result in these. So there's my left 4a minus plus 3 times 2a minus 3, and that'll be equal to 0. Because these are multi-step, maybe I can show all my work. Here's 4a plus 3. And thanks to the zero product property, you know that that's either 0 or that's equal to 0. So 4a plus 3 is 0. Or 2a minus 3 is 0. And we can solve these. And the left term, or the left value I get, is negative 3/4. And depending on how comfortable you are with these, maybe you stop showing that work later on. Add 3 to both sides of this one, and I would get a is 3/2. So when I summarize this, I would have a is equal to negative 3/4, comma, 3/2. Now, I definitely am not checking this by showing every single step, like multiplying 8 times negative 3/4 squared and all that, but I could retype this into my calculator and substitute these values in to make sure I get the correct answers. And on all the problems where this is new for me, you can bet I'm doing that to feel more comfortable with it. And then also, on a quiz or a test, you can bet I'm doing that as well to try to get full credit whenever possible. The second problem says 3x squared minus 5x equals 12. You're probably tempted to pull out an x, because that's what these old problems look like when you were told just to factor something like you had on the left side. But this is equal to 12, And that gets you no further to figuring out what the values for x are. And because of that, you have to make sure that by the end of a chapter test, by the end of the chapter when you're about to take a test, you have to recognize what each type of problem is. So I'll subtract 12 from both sides so that I get equal to 0. 3, 5, and 12, their greatest common factor as far as 1 would just be 1, so I can't pull anything out there. So now I'm going to look for the factors of negative 36 that add up to negative 5. Okay, I'm thinking about negative 6 times 6. Well, that doesn't work. That would be 0. Maybe I'm thinking about 1 and 36, 2 and 18, 3 and 12, 4 and 9. But we have to have the larger value be negative to get that negative 5. So I'm going to write 3x squared plus 4x minus 9x. One more time. Remember, this is what that term became. It became two separate terms so that we now have a problem with multiple terms. And so we could factor x from the left, giving us 3x plus 4. We can factor 3x from the right, leaving us with 3x. And I'm going to write minus 4 just for a moment because I'm like, oh, well, hold on, wait. This is not the exact same. And whenever you get something that's not the exact same, it means you need to look at your work and it's like, oh, okay, I factored out a negative there. That means I have to change my sign. I also realize that I made a mistake here. I should not have written 3x. Please erase that and fix that with just a 3. On the left, I'll write x minus 3 and 3x plus 4 on the right. The left part's easy to figure out. It would just be 3. And then if you're really comfortable with these, I can see that this would have to be negative 4/3 for this value of x. And as I'm doing these, I'm kind of picturing that in my head, and I'm like, okay, well, that would mean 3 times negative 4 over 3. These would cancel out. I'd be left with negative 4, and that negative 4 would then be added here, and it would go away. If you're thinking that was quick, then your next thing to do would be to pause the video and solve this when you set it equal to 0. But I'm not showing that work. Okay, I think I could probably check this positive value of 3 without my calculator just to kind of walk you through the thinking. X squared would be 3 times 3 is 9. And then 9 times 3 would be 27. 5 times 3 would be 15. And if I did 27 minus 15, I would get 12, which matches what we thought about there. So the more I do these, the more I want to check them and see if I can check these in my head. And you could do the same thing with negative 4/3. Here's negative 4/3. If I squared that, I'd get positive 16/9 times 3. These would become 3s. That's 16/3. And then 16/3 minus 5 times negative 4/3. And I get 16 minus 20/3, which would be negative, which doesn't really agree, which tells me I'm cutting too many corners. And what I just realized was I didn't flip the signs up here. So here, this would be negative and a negative to get positive, and 36 over 3 would really be that 12 value. So here's the work shown if you want to see it. So yeah, probably should be using those calculators there to check those out. Let's make this last one almost an OYO. And the reason that I say almost an OYO is, let's write it down. 2x squared minus 30x plus 88 is 0. Now, my first thought would be, well, 2 times 88, well, that's, 88 times 2 is 196. And, well, maybe I could save some time. From this problem, I was able to factor out a 2 and go about it this way. And maybe then, instead of looking for all that crazier stuff, I'm looking for the factors of 44 that add up to negative 15. And those factors would be negative 11 and negative 4. Now, go ahead and finish the problem on your own, factoring like one of the older ones we did, where you'd be like, well, x minus 11, x minus 4. And you'd be like, well, x is either 4 or 11. And if you would have used 2 and 88, the final result would be the same. But you can bet I'd rather do it when I have a value of 1 in front of my x as opposed to a value of 2, assuming it's a time saver. There you go. At a pep rally, small foam footballs are launched by cheerleaders using a slingshot. How long is a football in the air if a student catches it on its way down 26 feet above the gym floor? Now, before you do this problem, you need to know the equation that you would use, and that is h for height equals negative 16t squared plus vt, where v is velocity, plus s, where s is the initial height of something launched in the air. As it is, you don't have enough information to do this problem. So let's draw our picture first. Okay, so we have somebody standing here, and I do want you to sketch this as well. And they're pulling back a slingshot. And then we can draw the direction that the football would launch. And it seems like, it's being launched kind of high in the air, so maybe I want my picture to be more like that. And this person right here launches the ball from 6 feet up. So there's the height, roughly, of the person, or where the launcher is at. Now the other deal that we know is that this deal is being caught. How long is the football in the air if a student catches it on its way down? Okay, that's kind of interesting. 26 feet above the air. So I'm going to shorten this, and this is what it would look like if it was on its way down. So here's 26 feet. So if you want, you can draw a person with their hands stretched out, and they'd be on like a bleacher or whatever. And I guess the reason they point that out is because if this is on its way down, there's going to be 2 locations where the ball was actually at 26 feet high. So let's go ahead and rewrite our equation, but this time with the values plugged in. H equals negative 16t squared is what we're solving for, so we don't know that. Plus v, which we do know, and s, which we do know. But I'm rewriting it so that you have to rewrite it too. Okay, now here's the deal. The initial height we know. That's 6. We don't know time yet, but we do know the velocity because I'm telling you it. The velocity is 42 feet per second. So there's 42t. Negative 16 comes from gravity, so we keep what they give us there. But the h that I'm interested in is 26. I look at this equation. I have one variable, and I have only one equation. That means I can solve this. So I'm going to subtract 6 from both sides. But I like to see my t on the left, so I'm going to write negative 16t squared plus 42t equals 20. So I have to be careful not to make an error there. Now I'm looking at this and I'm like, well, I could try to subtract 20 now, but there's also the part of me that's like, I think I can divide all of these numbers by 4, except for 42, right? I think I can divide them all by 2. So maybe I show my work this way. I want to, take negative 1/2 of everything in there. And the reason is that'll give me 8t squared minus 21t equals negative 10. Add 10 to both sides. And it looks like I'm getting a little tight on room. Hopefully you're okay. 8t squared minus 21t plus 10 equals 0. I'm looking for the factors of 80 that add up to 21. So if I'm trying to get 80, I could do 10 times 8. That's no good. 1 times 80, 2 times 40, 3, no, 3 doesn't work. 4 and 20? Nope. So how about instead 5 and 16? So I rewrote that as 8t squared minus 5t minus 16t plus 10 is 0. Factor a t out from the left, I get 8t minus 5. I always kind of felt unsure when I got weird things like that, because I got so in the habit of seeing everything else being like 2s, 4s, 11s, whatever they might be. So hopefully you feel a little bit more assured when you get to the next part and you pull out a negative t, which leaves you with negative 2, which leaves you with 8t minus 5 is 0. Then we got t minus 2 times 8t minus 5 is 0. And this means that at 2 times, one where it's 2 seconds later, and another where it's 5/8 of a second later, this is 2 different locations where the height was 26 feet. But since it was talking about the way down, we would cross this out and then say 2 seconds later. And it's probably a good idea to say the ball was caught 2 seconds later, because that's a very specific way of finalizing the problem. Now that word problem may or may not have been super difficult. So, if it was, talk to me about it. And this section is all about factoring trinomials, where you have a value for a in the front. Same deal as before, got a lot of problems with this. See how they go.